outside a capillary tube, right? Yes, yes, yes. That's all about the traveling microscope. This traveling microscope we can use to measure the small distances as a diameter of capillary tubes and very small distances, and also the distance or the length of elastic objects. You may remember that thing, right? And today we discussed this instrument which used to measure the mass. Okay. Then write the topic as a measurement of mass. Measurement of mass. It's the measurement of mass. We know that that's a mass means that's the amount of matter contained in an object that's be considered as a mass, right? So we know that according to the gravitational laws, if any object they're having a mass, they attract towards the Earth center. That's some theory we'll discuss it later, right? So all the bodies which having a mass, they attract towards the Earth center because of Earth gravitational field. The Earth gravity pull, we also when you we also attach with this gravity, right? We all are directed towards the forces acting on us is directed towards the center of the Earth. That's why we can be in this Earth, right? So that's called the weight of the body, or that's a gravitational force, gravitational attractive force, right? And also this gravitational attraction or the gravitational field, that's different for a different place to place is different on Earth. And there are some many factors to depend on this, but we will discuss in the unit 5, the gravitational field lesson, right? Here, basically, I'm going to discuss that's weight or the mass of the body will be measured. That is by considering the weight by this Earth gravity. We can measure it without, because some balances are not work if there is no gravity. So that's how I'm going to, the gravitational balances are there. That's why I'm going to discuss this. So all the balances you measure the masses are not works in zero gravity place. So all the mass measuring instrument in what they can use to measure the mass in gravitational field only. So basically there are two types of balances, that is spring balances and the lever balances, right? That lever principle and spring principle we use to measure the mass. So that's basically we need to know. First we may write some introduction and then come to the instrument part, right? So try to give some introduction regarding this mass. Right there, the amount of matter contained in an object, amount of matter contained in an object can be introduced as the mass of the object. Can be introduced as the mass of the object. Right? Any objects the guy disconnected. I don't know why. Okay, right now. Right, that any object which having a mass, any object which have mass, any object which have mass is attracted by the earth, attracted by the earth and attracted by the earth and that attractive force is called the gravitational force. That attractive force is called the gravitational force or weight of the object, or weight of the object. Or weight of the object. Right, since the earth gravitational field, earth gravity, since the earth gravity is different, earth gravity is different from place to place, from place to place, and and it is and it varies, and it varies with the height, with the height from the earth's surface. Here is with the height from the earth's surface. The weight of the object is also, the weight of the object is also, weight of the object is also vary. That's change, right? Vary. So simply we can say that's the weight that's equals to the mass of the object multiplied by the acceleration of gravity. Jadi kan lihat kan ini weight kan ada W का same. Instead of this measuring the weight is a mass measure, the mass will not be changed. The weight can be changed according to the G is different. For Earth surface, we can consider it as a 9.81, but normally we consider in A level you can use it as 10 for the easiest of the simplification. Let's say we write this is true only for Earth surface. Okay, we can write the weight is mg. Then right, that's the acceleration of gravity. Acceleration of gravity at the Earth's surface is almost 9.81 meters per square second. Earth's surface is almost or approximately 9.8281 meters per second, and that is on and that is 1.67 meters per square second on moon surface. On moon surface. Okay, then thus when a mass of 10 kilogram body is considered, mass of 10 kilogram body is considered. Its weight at Earth surface that is 10 into 9.8281, that is 98.1 Newton, and its weight at the moon surface 10 into 1.67, that is 16.7 Newton. It is a weight different for different places. Someone I wanted you to tell this thing. And bigger around, then you can see that's a direct relation for the mass with the weight, right? Weight and mass, they have the direct relation. So then if you can measure the weight, then you can get the mass of the body. So that's the thing we are going to do, right? Because easily we can measure the mass, not weight, not the mass. Then we can convert it into the mass. Then right there, uh, however, however, since the mass is directly affected, since the mass is directly affected to the weight of the object, the weight of the object, the weight of the object, an idea about its mass can be taken, an idea about the mass can be taken by its weight, be taken by its weight. By measuring the weight, then you can take an idea about its mass, right? Okay, then you need to know that the one thing also. It's when if you are considering its weight and then take the mass using the weight, we call that mass is a gravitational mass, right? In the other case, if you can consider the mass based on the Newton's second law, that mass is called as the inertial mass. So both the masses are equal and not different, they are, right? But different principles we use to get the masses, right? That's a thing. Different phenomena we use. And put a stand right there. Put a stand right there. The mass obtained using the weight of the object. Mass obtained using the weight of the object. Weight of the object is called the gravitational mass. Is called gravitational mass. And gravitational mass and the mass obtained by using the Newton's second law of motion. The mass obtained by using the Newton's second law of motion is called the inertial mass. Is called the inertial mass. Okay, then right there. There are two methods. There are two methods to obtain the mass by using its weight. Mass by using its weight. The first one is right this. I'm measuring the weight. So by measuring the force here. By measuring the force using measuring the force using the extension or compression. Extension or compression of a spring. Compression of a spring. Of a spring. Right. Based on this principle, within bracket, right, what are the instrument we use? We call it string balances. String balance. String balance or masses minor. ME principle again. String balance. So another thing is called the table balance. Table balance clearly near very good. That's compression minor. Compression minor. Table balance again. Spring balance again. Kind of extension. Spring again. Compression, compress the both the consider cases we consider. I will come by one by. The second method is using the lever principle, right? Okay, then write the second one. Comparing the mass, mass weight, comparing the weight of an object, with the weight of the weight of the non-mass, the weight of the non-mass by using the lever method. Those the balances are within bracket, right? This is a triple beam balance. Normally, that's normal balances, and because the beam balances are based on this principle. Triple beam balance or four beam balance or any of the beam balances. Example on the image that is called. If you want to write this commonly, you can write as a beam balance. So all the beam balances are based on this principle. Clear? Okay. Now let's this. Then write is the spring balance. We'll discuss about the spring balance first. Right? Spring balance. Let's if we consider about the spring like unstretched string, and if you hang weight or mass on the spring will be extended, right? The string will be extended like this. And this amount of this extension we call this amount it is x, let's say is extension. And according to the Hooke's law, we can say that uh, the force acting on the string, and here it's weight is there downward, and force acting on the spring is F. So this F equals mg when they are not moving or no any at the equilibrium case you can say like that. So then according to the Hooke's law, this force acting on the spring is proportional to this extension. So then we can say that the mass hang on it is proportional to the extension. By measuring the extension, then you can directly get an idea about what is the mass of that. You can measure the mass in this. So that is the principle used in spin balance. First, you need to calibrate it with the known masses. You hang the known mass. Let's say 10 kilogram you hang. Let's say it's give the extension 10 centimeters. If 1 kilogram you hang, so then it gives the extension 1 centimeter. So then you can divide it in between these 2 points. It is of equal value, and then they make the spin balance, which similar to this. හදලා තියෙන spin balance data again. Okay. මොකක්ද හෙල්ලන්න ඕනේ මාස් එක ගෙල්ලුවාම short drawing like this. මේක directly combine නැති නේ. එයාවර indicator එක. This indicator is moving down. මේක තියෙනවා unit scale එක මොකක් හරි. So like that. You can get it. ඒ හදලා තියෙන්නේ එහෙමයි. For a known masses, the position, the 1 kilogram is there, 2 kilogram is there, 3 kilogram is there. So you hang the mass on it. It's the indicator will move to that point, and then you can say what is the mass of it, right? Okay, right? Right. Make it. First, you draw these two figures. Okay. And the other. Finish drawing, then let's say the force acting on the spring. The force acting on the spring is proportional to the extension or compression. of this. So here mechanics part when we theoretically we discuss this later more. F then proportional to x. If equals kx, the proportionality sign to remove the proportionality sign, you need to use the letter k. That's a constant. We call that k is the constant, right? It's called actually the spring constant. It's a constant for a given spring. The spring constant, right? It's k. Okay. So at equilibrium, because when you measure the mass, you hang the mass on it and you need to wait until it's come to the equilibrium. Equilibrium, then we can say that's the weight of the body that's equal to that force. That is kx here, right? The mass then equals to the, that is k over g or x. The g is a constant for a earth surface and k is a constant for a given spring. And then you can say that the mass of the body is proportional to the extension. So if you can measure the extension, then you can tell the what is the mass hang on it, right? So, because the, I will write after that, write as k over g is constant for a given spring. Given spring, then you can say that its mass is proportional to the extension, OX. Mass proportional to the extension, right? That by measuring the extension, you can measure the mass. Alright, so that's the principle behind this spring balance. Right. So erase this. If you finish the writing, raise your hand, then I can erase and then go to the next one. Alright, yang iwan na They write there. The spring balances are designed. The spring balances are designed based on the above principle. The spring balances are designed based on the above principle. Based on the above principle. Draw this, right? Orang Indonesia sama ini. Ini lagi ilan. Kalau lah pagi kan tadi. Ini sakura pagi ya. So like this. Ini ada ya ini. Oh nanti. Ada. Mình có cái spring cái đi. Spring này mình jadi baca ada. Nah, kemudian dia lang spring cái attach to this. Ini berada ini attach lagi. Ini tidak. Hal. Ini kira kira ini. Ini spring cái tekamu. Ini maintenance. Ada deh. Oke. Kan? Indicator or pointer. Ini kan remark है आपकी तरह तो hook है hook goes to and the mass හරි. නේද නියම. Okay, what we do first? First we hang the known mass there, right? So then according to the extension on the spring, I have to calibrate this spring balance. So that means if you, let's say, it is at the zero, no, if you no mass you hang there, that it is at there, the indicator is there. If you hang the 10 kilogram mass, let's say it's extend to this point, then you can divide the equal divisions between this region. Then it is equally bedalan. Then we know that if let's say 10 centimeters they given for 10 kilogram, that means 1 kilogram for 1 centimeter. So 1 centimeter for 1 kilogram. Then 2 centimeter for 2 kilogram. Then 1 millimeter for 10 gram, 100 grams. So likewise, you can divide equally and then you can get the measurement. The first the known mass hang on this balance and on the balance, and according to the extension of the spring, the spring balance is calibrated. The spring balance is calibrated. The spring balance is calibrated. Then it can use to measure the mass of the object according to the extension it made. According to the extension it made. According to the extension it made. Okay, that's about the spin balances, but we are not much used spin balances in the laboratory because normal spin balances we use to measure very large amount or large masses, right? So the kilogram or 10 kilogram, 5 kilograms. So normally the vendors use this. හරි. તો මේවා කරන්නේ පොළොවල බර කියන්න වගේ තමයි mostly use කරන්නේ. හරි. Soil resistance, right? Then write the beam balances. Beam balance. Let's see the principle based on this and then come to the practical used instruments. Okay, then right there. The principle of moment is used. The principle of moment. The principle of moment is used. Principle of moment is used to obtain the mass of an object. To obtain a mass of an object. Mass of an object for beam balances. So using beam balances. Using beam balances. The beam balances are work on the principle of moment, right? So what is the principle of moment? That is the moment about a point, that is when the system is in balance. So moment about any point of the system should equal to 0. That means that clockwise moment should equal to the anti-clockwise moment. But the moment means that the force multiplied by the distance, perpendicular distance to that force from the point we are taking the moment. Right? මේ තිබ්බොත් මේ පැත්තට මම බර දුන්නා මේ පැත්ත පාත් වෙනවා. මේක බැලන්ස් නම් මේ පැත්තෙන් එන බර මේ පැත්තෙන් එන බරට බරෙන් එන මොමන්ට් එකට ඉක්වල් වෙන්න ඕනේ. ඒක ලෙන්ත් එක වෙනස් කරාම වෙනස් වෙනවා. ඒකයි. දැන් මට පුළුවන් මේක මේ කෙරවලින් උනත් මෙහෙම බැලන්ස් කරන්න. ඒත් මෙතනින් මොකක් හරි මාස් එකක් එල්ලලා ඊට වඩා ලෝන් මාස් එකක් මේ පැත්තේ කොහෙන් හරි මේ ළඟකින් එල්ලලා පුළුවන් බැලන්ස් කරන්න. නැත්නම් ඈතින් එල්ලලා පොඩි මාස් එකක් නම් පුළුවන් බැලන්ස් කරන්න. ඒකට ඉක්වල් ඩිස්ටන්සස් වලින් ගත්තොත් තමයි ඉක්වල් මාස් එකක් දෙපැත්තෙම තියෙන්න ඕනේ. සාමාන්‍ය කඩවල වල තියෙන තරාදි වල ගන්න. අතන අපි නිකන් ලියාගමු mention the principle of movement කියලා. Principle of movement. මේවා වෙනම විස්තර කරනවා මේ ඉස්සරහා පාඩම් වල හරි. ඉතින් අදාළව මේක එකපාර බැලන්ස් එක කිව්වම මොකද්ද මේක වැඩ ගන්න කොහොමද කියලා දන්නේ නැහැ නේ. ඒකයි principle of movement. Then right there, in equilibrium system, in a equilibrium system, the clockwise moment about a point is equal to the clockwise moment about a point is equal to the anti-clockwise moment about the same point. Clockwise moment about a point is equal to the anti-clockwise moment about the same point. Let's say this is the B. So I'll balance it from this point, right? Let's say hang a mass on this side and the other side. Two masses. The left mass is M1. This weight is M1G then, and this might is M2G. And the length, so this mass from here is, let's say, L1 and this L2. Right? This point I'm considering, this point is O. So is the point there. This point is O. We are balanced it from the point O. right? We call this is called a knife edge actually. This balance it on a knife edge. And this so at equilibrium we can say then equilibrium state. Let's say that the moment about O that should equal to zero. That's why we call this a moment about O is zero means that's moment. This gives you that the clockwise moment is equal to the anti-clockwise moment. Clockwise moment, you get this one gives the clockwise moment. මේ පැත්තට හැරෙන්නේ මේකෙන්. So the moment you can write as m1g multiplied by the distance to this point, that is L1. Anti-clockwise moment is m2g multiplied by this distance. m2g, that's L2. G cancel. So then you can say yes, m1 that's equals to the L2 divided by L1 times m2. Right. That means if you know this L1 and L2 and M2, then you can find M1. So that's the way we measuring the mass. If let's say this mass is unknown one, and this is a known mass, and if you can measure this length with the balance case, then you can tell what is the mass of this. Right? By changing the length you balance, then also you can take the mass like that. So that's the principle of the beam balance. You can change this length and you can change the mass. අපි සාමාන්‍ය තරාජය කියන්නේ is to take in the same length. L1 L2 then equal. So if you place the mass on this side and then equal mass you need to place the other side to balance it. So at the balance case then you can say that the mass on the both sides are equal. So that's why in normal shops they measured this thing. එක පැත්තකට සීනි දානවා අනිත් පැත්තට තරාජි පඩියක් දානවා. පඩියට equal mass එකක් මේ පැත්තෙන් ගන්න පුළුවන්. තේරුණාද? Is it clear? You understand? Let me know. This is the principle behind the instruments, right? So, but this instrumental part is not much like this. මේක නිකන් instrument එක දුන්නාම මැනගන්න පුළුවන් තරාදී. That's principle. Is it okay? If you finish the right, let me know. Raise your hand, right? makan. Ada ni mana ada kira ada hen. Ibu ni mungkin. Ini kira ni kira na. Then method impress. If you select this L1 and L2 is equal, right? If L1 and L2 equal, then you can say that M1 equals to M2, right? That means if M2 is unknown and M1 is known, then you can say what is the mass that is equal to known mass. You need to know that you need to have there is the mass until that's equals to the other part. That's to be balanced. In the balance case, we can say then there are two masses which are equal to each other. You can write this if L1 equals L2, then M1 equals to M2. Then ඒ ක්‍රමයේ එච්චර හරියන්නේ නැහැ. ඒකට හේතුව දැන් මේකෙන්ම ඉඳ පුළුවන් known mass එකක් විතරනේ. කියන්නේ exact mass එකක් විතරයි ගන්න පුළුවන්. දැන් මට මේකේ mass එක හොයන්න ඕනේ කියලා හිතමු. If the mass of this is equals to the, let's say it is 75.5 grams වගේ එකක් කියලා. හරි. 75.5 grams විතර unknown mass හොයන්න අපිට බෑනේ. අපි දන්න තරාජි පරිදි තියෙන සාමාන්‍යයෙන් 20 gram 50 gram එතකොට 100 grams ඉන්නේ. ඒගේ පොඩි ඒවට නැහැ. ඉතින් ඒ ක්‍රමයේ එච්චර හරියන්නේ. ඒ හින්දා අපි කරන්නේ මේකේදී වෙන එකක්. එකක් known mass එක තියාගෙන මේ length එක change කරනවා. balance වෙනවා. දැන් මේ පැත්තේ මොකක් හරි එකක් එල්ලුවාම ඒකත් එක්ක balance situation එක එන තැනට එනකම් මේ mass එක එහෙට මෙහෙට වෙනස් කරනවා. අර balance වෙන තැනදී if you know this balance length and masses, then you can calculate this. That's the way we do it, right? So that's called the beam balance. We can slide the mass along the beam and then balance it. Then you can achieve the balance situation, and then by measuring the length from the pivoting point, and then you can, if you know the mass you shift or use slide, so then you can calculate the unknown mass using this equation. If you know the distances and the mass only, you can get it, right? Right there. And then it is difficult to find the known masses. It's difficult to find the known masses for all the unknown masses. So all the unknown masses to balance the beam. To balance the beam. Therefore, in beam balances, it uses in beam balance, it uses a certain known mass, and the balance length, which gives to the unknown mass. Then the beam can be calibrated. According to the masses, according to the different masses. මේක මෙහෙම හරි එක පැත්තක් fixed තියෙනවා. The one side of the beam is fixed. එකක් ලියන්න where one side of the beam is fixed. So one side of the beam is fixed. That means that's one side the mass you put and it's fixed position. Fixed. And only the other side the mass is sliding over the beam. And only the other side mass is sliding over the beam. මේව තියෙනවා මේ පැත්ත ටිකක් දිගට තියෙනවා ස්ලයිඩ් කරන එක. මේ පැත්ත අඩු. මේක හැමතිස්සෙම මෙතන එක ඉල්ලලා තියෙනවා නැත්නම් මේක උඩ තියෙනවා. හරි. This is fixed or fixed mass. Not fixed mass. You can put the mass anyone you want to measure. That this length is fixed. මොකක් හරි මෙතන පොක්කක් එල්ලලා තියන්න බෑ. එහෙම නැත්නම් මේක උඩින් පැටියක් වගේ හදලා තියන්න බෑ. උඩින් තියන්න. This length is considered as y length. Y distance. දැන් මේ පැත්තේ තියෙන mass එක it is sliding mass. මේක දිගේ එහෙට මෙහෙට ගෙනියන්න. So that mass that is also known mass. මේ mass එක change කරන්න. This sliding mass. That value is known. Right? It is known. And this is unknown. We need to find this. So this point is the pivoting point. That's an knife edge. This is a pivot. And made distance, you can change this distance as to get the balance situation. Right? According to the previous principle, so at equilibrium we can say that that's a mg y that's equals to the m naught g x. මේ මාස් එක මේ length එකකින් වැඩි කරනවා මේ මාස් එක මේකකින්. So then y you can write, sorry, the mass we need to find this. M you can find m naught divided by y and x. And y and x are constant. This length is a fixed length, right? A fixed. This is variable. It can be variable. It's very according to this mass. මෙතන වැඩි මාස් එකක් තිබ්බොත් මේක ටික එහාට ගෙනියන්න. අඩු මාස් එකක් තිබ්බොත් මේක තමයි ළඟට ගෙනියනවා. මේ මාස් ඒ length එක measure කරන. Then you can calibrate this beam according to the masses. So කෙලින්ම directly මේකේ beam calibrate කරලා තිබ්බම අපි તો මෙතන තිබ්බම 100 kilograms නම් 80 90 80 70 ඔහොම මේ පැත්තට calibrate වෙනවා. මේ තව දිගට තිබ්බොත් එහා පැත්තට යනකොට ඒක වැඩි masses වලට යන විදිහට හදා ගන්න පුළුවන්. So that's the way. That's mass proportional to the length. You can get it from this beam, right? Choosing m naught over y as constant, naught and y as constant. That's mass proportional to the x. Then beam can be calibrated according to the mass placed on this position. If you place a 100 gram, let's say it gives the value is there. If 200 gram is there, like that, you can divide into equal divisions and then get the smaller masses too. That's we can use this kind of beam balances to measure the mass up to the 0.01 grams accuracy. Can copy down. Okay, based on this case, that's because using the length you measure, that the triple beam balance and four beam balance are designed. Right up to this point. ඉස්සර තිබ්බ chemical balances ගැන මම මේක උගන්වන්නේ නැහැ දීතු chemical balance දැන් use කරන්නේ නැහැ කොහෙවත්. Analytical balances නම් තියෙන ඒවා course වල use කරන්න තියෙන්න අපි ගන්නවා කියන එක වැඩකුත්. If you finish drawing, raise your hand. Right? Amandiro? All right. So then write the triple beam balance. That's based on these principles. These balances are. Find the triple beam balance. Triple beam balance. Okay, I will draw the figure. For going to the figure is discuss. That's this case that simply I say that there are the beam. The one beam is divided into three. That's split into three parts like that one. And this beam now is pivoting somewhere here like that. So you can place a weight pan is there. So to place the weights then, and the sliding weights are on these beams. They can slide to it, right? So make a right cancel. So මෙතන තියන පොඩි ඉන්ඩිකේටර් පොයින්ට් එකක් තියෙනවා. මෙතන තියෙන balance point එක. දෙන්න 0 කෙලින් ඉනවනේ, so it's balance. මේක මේ වගේ මෙහෙම හදලා තියෙනවා. හරි. just end it. ලොකු රංගි නෑ. දැන් balance කරලා. මේ විදිහට තියෙන instrument එකක්. අපි මේක ළමයන්ගේ ඕනේ. The triple beam balance is the triple beam balance is a triple beam balance is a typical mechanical balance. Typical mechanical balance. Typical mechanical balance, right? It has a beam which is supported by a pivot of knife edge. We call it a fulcrum. And is supported by a fulcrum. Fulcrum. Within the guy is pivot. Pivoting point again. It's a knife edge can knife edge. On one side is a pan. On one side is a pan on which the object is placed. The pan on which the object is placed. On which the object is placed, right? Right. On the other side, the beam is split into three parallel beams. The beam is split into three parallel beams. Three parallel beams. each supporting one weight. Each supporting one weight. Each supporting one weight. Each supporting one weight. Simple stop. And then in measuring the weight of an object, measuring the weight of an object, measuring the weight of an object, rather than adding additional weights, rather than adding additional weights, rather than adding additional weights. Each of the three beams, sorry, each of the three weights can be slide along the beam, can be slide along the beam, be slide along the beam to increase their lever arm, to increase their lever arm. Then you draw this circle, right? Seems to have ගන්න ස්කෙච් එකක් විතරක් කරගෙන ලොකුවට ලස්සන කරගන්න ඕනේ දැන් මේක තියෙන මේක ඇතුලේ හරි පෙට්ටියක් වගේ උඩ පල්ලෙහා යන්න okay right call එකක් ආවා බේස් එකක් හරි නිකන් කාණු වගේ මේක ඇතුලේ තියෙනවා මෑතස් ටික ඒවා එළියෙන් අඳිනවා දැන් මේ ස්ලයිඩින් ආම්ස් තියෙනවා Yeah, they are very gross. I will name this. Yeah, maybe the or groups. ඉතින් කට්ට ටිකක් තියෙනවා. තමයි weights. මැද තියෙන එකේ තියෙන්නේ නම් අඩු ප්‍රමාණයක්. මේකේ වගේ කට්ට නැහැ. ඒක continuously මේවා කරන මේස් එකක් මේකයි. මේක දිගේ එහාට මෙහාට ගෙනියන්න පුළුවන් මේ වගේ මේස් එකක් තියෙන එල්ල. හරි. ඒක mass එක about 6.5 grams විතර. ඒක those are sliding masses. ඒ පොඩි arrow එකක් වගේ එකක් තියෙනවා. ඒකෙන් අර හරියට මෙතන කොතනද තියෙන්නේ කියන එක අඳුර ගන්න පුළුවන්. වෙන්න. තමයි ඒක තියෙන්නේ. අනිත් දේවල්ත් ඒ වගේම මේ තියෙනවා. මේ ස්ලයිඩ් කරන්න පුළුවන්. තව ලොකු මාස් අකට වඩා. මේ පල්ලෙහාට එල්ලලා තියෙනවා. පේන්නේ නැහැ ඉතින් මේක. ඉතින් හරි. ඒකෙත් ඒ වගේ එකක් තියෙනවා. මේකේ තියෙන එක තමයි ලොකු මේක. අනික පොඩි ඊට වඩා. මේක තමයි කැලිබ්‍රේට් කරන්නේ. yes 0 1 2 3 4 5 6 7 8 10 විදිහට අහමු. මේ ඩිවිෂන් වලට අහමු බෙදලා තියෙනවා. මේ බීම් එක විතරයි එහෙම බෙදලා තියෙන්නේ. මේ බීම්ස් වල තියෙන්නේ ස්ටෙප් වයිස් එහාට මෙහාට කරන්න පුළුවන් විදියක්. මේ බීම් එක අත දෙන 100 200 300 400 500 up to 500 10 20 30 40 50 60 70 80 90 100 වෙනකන් දෙනවා 90. ඒවා මම වෙනම ලියන්න දෙනවා. This is a stable beam. Other than this, there are another 2, 3 ways. එකක් ලොකුයි පොඩි. This indicator 500. මේ ගහලා තියෙන මෑස් එකම නෙමෙයි ඇත්ත මෑස් එක. හරි. මේ ඉන්ඩිකේටර්ස් මෑසස් only. ඉන්ඩිකේට් කරනවා ඔය 500. මෙතන මට අන්තිමට අමතක වෙච්ච එකක් තියෙනවා මෙන්න මේ කෙලවරේ පොඩි ඇනල එකක්. මේකේ කෙලවරෙත් එහෙම යනවා. Adjust it at x and y. x and y යන්නේ. පොඩි ස්කූ දෙයක් තියෙනවා. මෙන්න මේවා ඒකේ එල්ලන්න පුළුවන් ගානට තියෙනවා. දැන් මොනවා හරි මෑස් එකක් දානවා නම් තියනවා නම් තියන්න. Install the pan. The pan. So this is set. Zero adjustment. Just or adjustment. Zero adjustment log. Oh, is good. Screw කියලා කියන්නේ. හරි. මේක මෙතන මතේ තමයි pivot වෙලා තියෙන්නේ. මෙතන තමයි pivoting එක මෙහෙම ඇතුලෙන් තියෙන්නේ. Pivot එක. This is a pointer. This is a zero indicator. මෙන්න මේකට මේ දිගට මේ ඇලුමිනියම් පටියක් කොහොමද සම්බන්ධ වෙලා ඇලුමිනියම් සාහය. මේක පේන්නේ මම මේක කියන්නේ ඇලුමිනියම් plate. ඇලුමිනියම් plate එකක් තියෙනවා. ඒක පස්සේ කියන්නේ ඒක මේක ඇතුලේ තියෙනවා magnetic damping system. magnet එකක් තියෙනවා. හරි. අත් නම් කියන්න දෙන්න. magnetic damping system. ඒකට තමයි අර ඇලුමිනියම් ප්ලේට් එක තියෙන්නේ. දැන් පොයින්ට් එකට කනෙක්ට් වෙලා තියෙන පොඩි ඇලුමිනියම් තහඩුවක් පල්ලෙහාට තියෙනවා ඒක. මූව් වෙනකොට ඒකත් එක්ක තමයි එහෙට මෙහෙට මූව් වෙන්නේ. So these are the sliding masses, right? Pivot එක sometimes hiding weights. මේවල riders කියලා කියනවා. rider. Dynamic pain. මෙතන 0 positions තියෙනවා මේක. මේක line එකක් වෙනකොට මේක z dash here. These masses are considered as that is. Then අපි කියන්නේ 0 stop n for sliding weights. 0 stop n for sliding weight. ඉතින් එහාට යන්න බෑ. beams or calibrated beams. Three beams are there, triple beam can calibrated beams. Where scale we call it a calibrated beam. First, when we another make a pain on the make a this y, and this x. XI ගැන ඇන දෙයක් තියෙනවා. හරි we call this as a metal weights hanging points. Metal weights hanging points. This is the pointer, right? So what's the zero indicator? Zero indicator. All right. These are indicator weight. Indicator weights means that's 500 gram indicator weight. That's the indicator only. The actual mass of this is different, right? The different value. I make it got that make it that's I'm writing this as the mass of this is let's say MP. Maybe masses. This is MP, and this one as MQ, and this one as MR. So you can make that. The MP is about 6.5 grams. So MQ is about 300 grams. MR is about 70 grams. ඇත්ත වැලිස් ගත්තොත් එහෙම වගේ එකක් තමයි ඔකේ එල්ලලා තියෙන්නේ. ඉවන දැනගන්න ඕනේ මේ මෑසස් හරි තියාගන්න ඕනේ. පැත්තකින් තියාගත්තොත් තමයි. මේකෙත් එහෙම 500 කියන එකේ ඇත්ත ගාන 148.5. මේක 298. ඉගෙන ගන්න. ඇත්තාගේ. මේ ඕනේ තියාගන්න MP උදාහරණ කියලා දෙන්න. කියලා බලන්න මේ pivoting point එකේ ඉඳන් මේ තියෙන distances නම් measure කරන්න. distance is a නිකන් ලකුණු කරන්න. මේකේ මේ zero position එක තියෙනවා. zero indicator position එතන තියෙන දේ B. මේ end එකට තියෙන මෙතන ඉඳන් distance is called as C. The moments ගන්නකොට ඒ දුරවල් ටික තමයි වැදගත්. But you don't need to take this length because the indicators they are මේවේ හරියට mass එක කියලා තියෙනවා. What is that? So based on these positions of these masses මේ තියෙන මේක balance වෙන තැනට මේක directly you can read it. Direct reading you can take and using this instrument. Okay, you can draw this one. You couldn't hear it. This board one is not clear. I send it to the group. Okay. See drawing. The rough sketch below, not the exact one will go. Exact one will go. Rough sketch right now. And then you how much? Right. Finish, ne? Okay. The video share. Can you see this? Can I? This is the pan, this is the zero adjustment knob. I am show you. This is the pan, right? This zero adjustment knob and the pivoting point like this, right? So these are the three beams there. Can you see? And these are the weights, the smaller weights. That's the larger one, this there, and also smaller one. And this is the bend. You can see that the aluminum plate is there, right? This is the aluminum plate. These are these that indicate negative negative. It's indicated. There, I'll show another. It's because they take a comparison. This one is another. All are same like this, right? These are the chemical balances. Chemical balances are main thing. වගේ පොඩි weights තියෙනවා මේ weights වල අදාළ ඒවා විතරයි මෙච්චර ගන්න පුළුවන්. This also 4 beam balance එක. මේකේ beam හතරක් තියෙනවා අර වගේ නෙමෙයි මේක මේක ඊට පස්සේ බලන්න. This is a different mode එක. Let's go. මේ සාමාන්‍ය lab එකක තියෙන ගොඩක් ස්කූල් lab එක. The 4 beam balance. Hi, I'll share those photos with you so you can get an idea. Actual pictures I'm showing, right? Okay. Then these beams, how these beams are calibrated, we need to know about it. Right there, the beams of the triple beam balance, the 3 beams of the triple beam balance, the 3 beams of the triple beam balance are calibrated as below. Are calibrated as below. This front beam එක front sub beam කියලා අපි කියන්නේ, right? The front sub beam is right from sub beam. Opus beam කිව්වත් ඒක ඉන්නේ. Okay, right? ඉස්සරහා තියෙන එක. It is calibrated from 0 to 10 grams with 0.1 gram division continuously. Hi. Can make me 0, 1, 2 විදිහට මේවා වෙනම 10කට ආයෙ බෙදලා තියෙනවා. ඒත් මෙතන මෙතන 1 gram එක පොඩි point එකක 0.1 grams වලින් තමයි ඒක divide කරන්නේ. So you can write there the front sub beam, you can write there. Right there. This beam is calibrated from 0 to 10 grams. This beam is calibrated from 0 to 10 grams with 0.1 gram divisions. With 0.1 gram divisions as the sliding mass can be continuously slide on this. Can be continuously slide on this. Continuously slide can't pull on me. Maybe continuously slide can be. Maybe I make glue a glue again. So it's step like discretely calibrate color. Make a continuously calibrate. You can think continuously slide on. Okay, you can make a 0 to 10 again. What is the maximum mass you can measure from this beam? That is 10 gram. The minimum is 0.1 gram. Clear? And thus, the maximum mass can be measured using this beam is maximum mass can be measured using this beam is 10 grams. This beam is 10 grams. Okay. Write the second one. The middle sub. Middle sub beam. Okay, the middle sub beam is calibrated from 0 to 500 gram with 100 gram divisions. As a step calibration, step by step continuously discretely calibrate. 100 වලට පස්සේ ආයි 150 එහෙම මොකුත් ගන්න බෑ. ඒක 100 and then 200, then 300, 500, 400 and 500. That's all. Right? You under that, right? This beam is calibrated from 0 to 500 gram. 0 to 500 gram by 100 gram divisions. With 100 gram divisions. With 100 gram divisions. Then the sliding mass can be slide step by step. The sliding mass can be slide step by step within bracket, right? Discretely, continuous minute, discretely. Slide discretely, so step by step along this beam. So then the maximum mass you can obtain using this beam is 500 gram, right? Right, the maximum mass can be measured using this beam is 500 gram. The maximum mass can be measured using this beam is 500 grams. Then write the third one, back sub beam. Back sub beam, third beam, right? So it is calibrated from 0 to 100 gram with 10 gram divisions. And also it's calibrated discretely. That's the sliding mass can be slide discretely. Right? This beam is calibrated from 0 to 100 gram. This beam is calibrated from 0 to 100 gram. To 100 gram with 10 gram divisions. With 10 gram division. Then right, the sliding mass can be slided discretely. That means step by step. Sliding mass can be slided step by step or discretely along this beam. Right, the maximum mass can be measured using this beam is 100 grams. Maximum mass can be measured to obtain using this beam is 100 grams. Right. Okay, then according to this, the maximum mass you can measure using these beams only these three beams, that is 500 from the middle, 100 from the back, that's all together 600, 10 grams from the front. The maximum is 610 grams. Only using these 3 beams. But if you want to measure more than this 610 grams, you can use these indicator weights. How you can use this? You hang this 500 grams on this nail at the end of the beam. Then it directly gives the value 500. So that means if you hang this mass on this nail, so it equals to the 500 grams you place on this beam, this pen. If you place the 500 grams there, so if you hang this on this nail, so they balance. So that means if you hang this 500 there, so it starts the measurement from 500 there. The minimum value obtained is 500 there. So then another 500 you can, and if you hang the 1000 grams, similarly it gives 1000. There are only 2 nails. At once you can hang only 2 indicator weights. So then the maximum you get, this maximum 2 you can hang on them. Then it's 200, 2000, sorry, 2000, and another 610 you can take from these beams, and the maximum mass you can obtain using the triple beam balance is 2610 grams only. Right? So it is easy to understand this. Normally in this triple beam balances, they indicate this as the MB26010 as a name. Okay, a model name MB2610. It means that the maximum mass you can obtain is, that is 2610 grams. Clear? Is it clear? Okay, then write, put that right. Thus, the maximum mass can be measured only using the 3 beams. Maximum mass can be measured only using the 3 beams. Only using the 3 beams of the triple beam balance is, the 500 grams plus 100 grams plus 10 grams corresponding 3 beams. That is equal 610 grams. Under 10 grams. Okay, after that, right? But additional to this, additional to this, there are 2 metal weights. There are 2 metal weights that indicate 2 metal weights that indicates 1000 grams, and 1 metal weights that indicate 500 grams. There are 2 metal weights that indicates 1000 gram, and that indicate each 1000 gram. That indicate each 1000 gram, and 1 metal weights which indicate 500 grams. Right. Then override, they can hang at the position of the metal weights hanging points. At the position of the metal weights hanging points, that is X and Y, within bracket write X and Y, metal weights hanging points at the end of the beams, which are at the end of the beams here, at the end of the beams as required. As required. based on these weights hang on this place. Based on these weights hang on X and Y, Kevin, on X and Y. The maximum mass which can be measured, maximum and minimum masses. The maximum and minimum masses can be measured using this triple beam balance. This triple beam balance or vary as follows. Vary as follows. If nothing on at X and Y, right? Both that. Then the minimum reading, or that we call the least count, minimum reading, or we call that the least count, that's equals to the 0.1. That's 0.1. Now we get, and the maximum reading is only by the beams, right? Already given that is writing that the maximum is 610. This without any masses hang on this, right? That's the way. Then when you hang the masses on this X and Y, let's say only one mass you hang. So at the 500 one, so minimum is starting from it's 500 because the minimum mass you obtain is 500 with that one, right? ඒක අයින් කරන්න ඕනේ ඒක 500 නැතුමයි. අඩුවයි තමයි. Okay, I will erase this part, right? අනිත් එක මම මේ table එකක ලියන්න. Easy. This is the location and this side minimum and maximum. Minimum reading and the maximum. First one is no masses at X and Y. කලින් එක 0.1 gram and this is 110 maximum. And then my second one, that's 500 gram indicator, 100 indicator mass at X on. X on without that is 500 is the minimum. Maximum 500 plus this 610, 100, 1110 gram. තේරුණානේ ඒක කියන්නේ මේක 500 මෙතන එල්ලුවේ ගම ඒක ස්ටාර්ට් කරන්නේ 500 වලින් මේ බීම් එකකින් විතර තව 610ක් යනකම් මයින්ඩ් කරලා 500 to 1110 වෙනකම් ඒකවල මයින්ඩ් කරලා Then third one, this 1000 make a x at x o at y. Taking O නම් ගන්නක එක තැනක විතරක් එල්ලද. Indicator mass නම් it's hung at එල්ලලා. This is then the 1000 gram indicator mass hung at x o y only, right? ඊළඟ එක 1000 එල්ලුවා. එතන starting of 1000. Then 1610 you can get the maximum. Then is fourth one is 500 gram getting at x and 1000 gram at y position. දෙකෙන් මොකක් හරි කරනවා එකක 500 අනිකේ 1000 තියෙනවා. So then starting from 1500 and end with the 2110 gram. මේ දෙපැත්තම දෙකක් කියලා තියෙනවා. මේකේ 500 මේකේ 1000. ඒතර 1500ක් කෙලින්නේ. මේ පැත්ත ගෙනීම පල්ලෙහාට 1500කින් බාර ගන්න. ඒක 0 පොසිෂන් එකට ගන්න නම් මෙතන තියන්න ඕනේ 1500ක්. 1500 තමයි කියන්නේ ඉනිෂියලි ගන්න පුළුවන්. ඒතර ඊට වඩා වැඩි නම් මේක ඉතුරු ටික බීම් එකෙන් එහාට මෙහාට ඇඩ්ජස්ට් කරලා ගන්න පුළුවන්. කියන්නේ අපි කියන්නේ බැලන්ස් වෙනකම් බීම් එකේ තියෙන මේ ස්ලයිඩින් මාසස් එහාට මෙහාට කරන එක. Right. Then last one enough space එකක්. Last again, those both 1000 grams indicators are at x and y. Right. Both 1000 gram indicators are at the x and y position. X and y. So then minimum is 2000 and maximum is 2610. අනේ දෙක තියා ගන්න පුළුවන් නේ. 4000 gram indicator masses are at x and y. So minimum is then 2000 and maximum is 1610. Then I want to hurry up to now. If you have any doubts or any questions, you can ask. ඊට පස්සේ මේකෙන් මෙෂර් කරන්න හැටි නම් මම පොඩ්ඩක් කියන්න තියෙන්නේ. But that is stop the class for today. So we'll discuss next week the other part, right? Hello. ළමයි නිදිද? Okay, okay. ඉන්නවනේ. හරි ඔය ටික පොඩ්ඩක් බලන්න ඊට පස්සේ next week I will explain this then next week we can do the physical class. I think this the flooding is there on the road in a පාරේ මම අතුරු දාලා කියලා කිව්වා මං ඉතින් ආයේ bicycle කොහොමද උදරන් හැබැයි වැස්සේ නෑ තවත් අඩුයි හරි අපි ඊළඟ දවසේ බලමු. හරි. bye.